class is being live now. Okay, guys, I remember that we finished here in this slide right here. We were, you know, talking about this section here, and then we were supposed to continue in this one. Okay, so this is the Amazon ECS cluster options, right? When you create an Amazon EC2 cluster, ECS cluster, you have three options: and a working only cluster, powered by AWS Fargate, and we spoke about Fargate before, which is a serviceless container service. You can also have a Linux EC2 plus networking cluster, and also an EC2 Windows plus networking cluster. That's what we saw on Monday. I show you when I open the ECS service, I show you the three options that we have there. Now, if you choose one of the two EC2 launch type options, you will then be prompted to choose whether the cluster EC2 instances will run as on-demand instances or spot instances. Remember that I just demonstrated that. In addition, you will need to specify many details about the EC2 instances that will make up your cluster. The same details that you must specify when you launch a standalone EC2 instance. Same thing. It's like a template, right? Now, by doing this, the EC2 instance launch type provides more granular control over the infrastructure that runs your container application, because you manage the EC2 instance that makes up the cluster. Okay. Now, ECS keeps track of all the eCPU, memory, and other resources in your cluster. So Amazon ECS also finds the best server for your container based on your specified resource requirements. If you choose the networking only Fargate launch type, then the cluster that you will run your containers will be managed by AWS. With this option, you will only be package your application in containers, specify the CPU and memory requirements, define networking and IAM policies, and launch the application. And you do not need to provision, configure, or scale the cluster because it's managed by AWS. It removes the need to choose server types, decide when to scale the cluster, or optimize cluster packing, because Fargate option enables you to focus on designing and building your applications, nothing else, as it is managed. Like we talked about before, when it's managed, you don't have to worry about anything else. AWS will just take care of that for you. Okay. Now we also have Kubernetes. Kubernetes, it's an open source software for container orchestration, and it can work with many containerization technologies, including Docker, for example. Now, because it is popular and is open source, a large community of developers and companies build extensions, integrations, and plugins that keep the software relevant, and new and in-demand features are added frequently. So, like for example, Linux is an open source operating system. So as it is open source and people don't have to pay for licensing or anything like that, like Windows or Mac OS, then it has a lot of support and a great documentation out there, because there are many people that are constantly adding features and support, and people document the things that they do. So it does complement Docker, right? And Docker enables you to run multiple containers on a single operating system host, right? Kubernetes orchestrates multiple Docker hosts nodes. Now, it enables you to deploy and manage containerized applications at scale, so in big amounts. With Kubernetes, you can run any type of containerized application by using the same tool set in both on-premise data centers and the cloud. So with Kubernetes, what you can do, guys, is manage a cluster of compute instances called nodes, right? And it runs containers on the cluster, which are based on where your compute resources are available and the resource requirements for each container. Now, containers are run in logical grouping called pods, right? Now, you can run and scale one or more containers together as a pod. Each pod is giving an IP address and a single domain name system DNS name, which Kubernetes uses to connect your services with each other and external traffic. One of the advantages of Kubernetes is that you can use it to run your containerized applications anywhere without needing to change your operational tooling. For example, applications can be moved from local on-premises development machines to production deployments in the cloud by using the same operational tooling. Kubernetes automates container provisioning, networking, load distribution, and scaling. Now, Amazon Kubernetes, also known as EKS, you can run Kubernetes on AWS because you have this service, EKS. As I said before, Kubernetes is it's a third-party service, right? So maybe you might think that you could launch one or more EC2 instances, right? Install Docker on each instance, install Kubernetes on the cluster, and manage and run Kubernetes yourself. That is an option. That's possible. But AWS provides a service called this one, EKS, right? And that simplifies the management of Kubernetes clusters, right? So you can, like I said before, you can have Amazon EC2 instances. You can install Docker on those instances, and then you can install Kubernetes, right, on the cluster, right? That is an option, but it's better to use EKS, and that's gonna manage everything for us, okay? Now, this is a managed service, right? It's a managed service by AWS, and it makes it easy for you to run Kubernetes on AWS without needing to install, operate, or maintain your own Kubernetes control plane, right? Because it's like when you have an EC2 instance and you want to run a database on top of it, then you have to manage the engine, right? The database engine. The same thing, right? When you have Kubernetes on its own, right? You have to work with that with Kubernetes. But if you have EKS, then it will be managed for you. It's the same case as if you have RDS, you don't have to manage, you don't have to patch, you don't have to upgrade, you don't have to install the engine, the database engine. Okay. Now, Amazon EKS automatically manages the availability of and scalability of clusters nodes that are responsible for starting and stopping containers, scheduling containers on virtual machines, storing cluster data, and other tasks. It automatically detects and replaces unhealthy control plane nodes for each cluster. You can take advantage of the performance, scale, reliability, and availability of the AWS cloud, which includes AWS networking and security services like application load balancers for load distribution, IAM for role-based access control, and VPC for pod networking. So as you can see, this guy has a lot of advantages, right? It can support Linux and Windows containers, right? So it's not only specific operating system, it supports both the most popular ones, right? Now it's compatible with Kubernetes community tool and supports popular Kubernetes add-ons. So like I said before, it has a lot of documentation and support out there. So this guy will manage the clusters of the Amazon EC2 compute instances, and it will run containers that are orchestrated by Kubernetes on those instances. So this guys is the deal. It's a whole package, okay? It's a whole package for those companies that are implementing Kubernetes in their applications. Okay. So we talked about this guy before, right? This is a fully managed Docker container registry, right? It's where you can, register the Docker images, right? It makes it easy for developers to store, manage, and deploy Docker containers images. It is integrated with ECS, I'm sorry, Elastic Container Service, right? And so with this integration, right? With this integration, you can store, run, and manage container images for applications that run on Amazon ECS. What you have to do is to specify the Amazon ECR registry repository in your task definition, and Amazon ECS will retrieve the appropriate images for your application, right? So here we have a video on container services. Let us just watch that video.
Welcome. This video will provide an overview of AWS container services. You may be thinking, what are containers? Containers are a method of operating system virtualization. Containers are smaller than virtual machines and do not contain an entire operating system. Instead, containers share a virtualized operating system and run as resource-isolated processes. Containers offer several benefits. First, they support repeatability. Additionally, containers deliver environmental consistency because the application's code, configurations, and dependencies are packaged into self-contained execution environments. Next, they can help ensure that applications deploy quickly, reliably, and consistently, regardless of the deployment environment. Lastly, in terms of space, container images are usually an order of magnitude smaller than virtual machines. Spinning up a container happens in hundreds of milliseconds, resulting in faster launch times than traditional virtual machines. In order to understand containers, it's helpful to know a little bit about Docker. Docker is a software platform that packages software, such as applications, into containers. Docker is installed on each server that will host containers, and it provides commands that you can use to build, start, or stop containers. Containers are created from templates called Docker images. Containers have everything that an application that you want to run needs, including libraries, system tools, and the application code, as well as any runtime libraries. Many people who are first introduced to the concept of a container think that the containers are exactly like virtual machines. However, there are some key differences. One significant difference is that virtual machines run directly on a hypervisor, while containers run on any operating system if they have the appropriate kernel features to support Docker host software and it's present. The right of the diagram shows a virtual machine VM-based deployment. Each of the 3 EC2 instances runs directly on the hypervisor that is provided by the AWS Global Infrastructure. Each EC2 instance is a virtual machine. In this VM-based deployment, each of the 3 apps runs on its own VM, and each VM provides process isolation. The left of the diagram shows a container-based deployment. Here you see that only one EC2 instance runs a virtual machine. The Docker engine is installed on the Linux guest OS of the EC2 instance, and there are 3 containers. In this container-based deployment, each app runs its own container, which provides the process isolation, but all the containers run on a single EC2 instance. The Docker engine is present to manage how the containers interact with the Linux guest OS, and it also provides essential management functions throughout the container lifecycle. In an actual container-based deployment, a large EC2 instance could run hundreds of containers. Given what you now know about containers, you could launch one or more Amazon EC2 instances, install Docker on each instance, and manage and run the Docker. Specify the number of tasks that will be. Or yes, you will have more granular control over the cluster, and the cluster will run on EC2 instances that you manage. To manage the cluster yourself, choose either the EC2 Linux Plus networking or the EC2 Windows Plus networking cluster option. You will need to specify details about the EC2 instances that will make up your cluster. the same details you specified when launching a standalone EC2 instance. If you don't want to manage the cluster yourself, choose the Create a Networking Only cluster. Networking only Amazon ECS clusters are powered by AWS, including the cloud. Kubernetes can work with many orchestration containerized technologies, including Docker, because it is a popular open without needing to install, operate, and make with flexible options. You can decide which option best matches your needs. One challenge of deploying applications on containers is keeping track of, storing, and managing all of those containers. To keep addressing this challenge, AWS provides the Amazon Elastic Container Registry, or Amazon ECR service. It is a fully managed Docker container registry that makes it easy for developers to store, manage, and deploy Docker container images. It is integrated with Amazon ECS, so you can store, run, and manage container images for your applications that run on Amazon ECS. When you specify the Amazon ECR repository in your task definition, Amazon ECS will retrieve the appropriate images for your applications. Amazon ECR supports team collaboration, access control, and third-party integration, and it's also possible to use Amazon ECR images with Amazon EKS. Thank you for watching. We'll see you in the next video.
So guys, yes.
Welcome. This video.
Okay, so these videos, you can watch them in your modules, right? Right here, you have all the videos that you can watch if you have any questions about a particular service. So you have a lot of things here that you can watch. Okay. So the video you just talked about, these guys, you can use, you know, for Amazon ECS integration, Docker support, team collaboration, access control, third-party integration. So basically, this guy, what it does is you know, stores your images, Docker images in a repository. And then you can pull that when you define that in the task definition. In the ECS service in AWS, there's a section that says task definition, and then you can specify where that image is, and then it will pull the images, Docker images, to run your containers. Okay. So of this section, you know, containers can hold everything that an application needs to run. Okay, it has everything: the operating system, the software, everything that application needs. Docker is a software platform that packages software into containers. So a single application can span multiple containers. Right? Amazon Elastic Container Service (ECS) orchestrates the execution of Docker containers. Kubernetes is open source software for container orchestration. And Amazon Elastic Kubernetes Service, Amazon EKS, enables you to run Kubernetes on AWS. And also, Amazon Elastic Container Registry, Amazon ECR, enables you to store, manage, and deploy your Docker containers. All right, wait, I'm just reading this because this is the summary of what we covered earlier. Okay. Now, Lambda, a super powerful and amazing, service. It's serverless. Okay, there's no new languages, tools, or frameworks to learn, right? So Lambda supports multiple programming languages, including Java, Go, PowerShell, Node.js, C#, Python, and Ruby. So your code can use any library, either native or third party. So this guy completely automates the administration. Okay. So you can create automate tasks with this guy. Okay. I can create, let me see if I can do something for you guys. Let me find something here. And I see if I can schedule a cron job that will stop the EC2 instances today for you guys to see it. Okay, let me find that code here in my good. Let me see. Let me create a Lambda function. We come here and say AWS, and then let me access my account. Okay. Let me show you how it works. Okay. So I'm gonna come here, say Lambda, and then I'm gonna create a function, and then I'm going to call it stop my EC2 instance. Okay, I have to remember this name. Okay, and then I'm gonna use Python 3.8. Okay? I'm going to use a role because remember, I have to have a role that allows an interaction between Lambda and, let me see here, use an existing role, the Lambda function, stop my EC2 instance right here. Okay, right. So I'm gonna create this function here. Okay, and then I'm gonna create that function here. Okay, so that's gonna create my function for me. Okay, so I'm going to delete this guy here because I'm gonna use this code. I'm gonna use this guy, which is the bottle. It's the SDKs for developers. It's a library for developers, right? Now I'm going to have this. Let me see. First, I have to see if I have an instance here. Okay, so I'm gonna open this guy, and let me check the EC2 instances if I have one. Okay, I have 3 running, which is not good. I don't know why I have this. Well, I have the container one running. Okay, let me terminate that guy. Okay, so I'm gonna terminate, stop it. Okay, if it's stopped, I'm not charged for it. All right, so I'm gonna use this guy. I'm going to terminate this one. You see, okay. So I'm gonna terminate this one. That is terminate this guy. Okay. If I refresh this, it's still running. Let me see if I can terminate this guy. Terminate this guy. Right. So I'm going to grab the ID of this guy, and let me see what region it is in. So it's US East 1. So I'm gonna come to the Lambda function, right? And I'm going to go back here and say region. I'm gonna declare the variable like I do in Python, and then say East 1, right? So East 1. So I'm gonna say instances, right? I'm gonna say this guy because I'm going only stopping 1. If I'm stopping more than 1, then I have to do this, right? And it will be an array of instances like this, for example. And then I have another one here, okay? But I only have 1, so I don't need to have an array. I'm just storing the ID of that particular instance that I'm stopping. So now I'm gonna have a variable named EC2 instance, EC2, and then I'm gonna say bottle, right? And then I'm gonna say client. I'm gonna pass the EC2 service that I'm working on, right? And I'm passing the region, right? I'm passing the region name, which is region, the variable that I created before. Okay, so it has 2 parameters here, right? I'm passing the first one, which is the service I'm working with, and I'm passing the variable region name, and I'm assigning this guy to the dot variable, assigning this guy. So basically the value of this is US East 1, right? Right now, I want to create a function in Lambda, starts with def, right? And I'm gonna call it Lambda handler. This is the guy that handles whatever is going to be worked on in this function. I'm gonna pass this 2 parameters, event and context. Don't worry about this, guys. This is the way you do in Python. I'm gonna path that. I'm gonna say EC2, right? That's the variable that I created here, right? And I'm gonna say stop instances, okay? And now I'm gonna say instance IDs, right? And now I'm going to pass, you're going to assign this variable here, which is the ID of the instance, right? Now, I'm going to print something in the console, in the Lambda console. I'm going to say stopped, just stopped my instance. And then I can say space, there's a plus, and say str. Okay, we're just converting that to a string and say instances. Okay, so as simple as that. This will stop an instance. Okay, now we have the instance running here, right? It is running right now. Oh my God, I know why. It's the auto scaling working. Remember I created auto scaling on Monday? I didn't delete that guy. So it's constantly creating things for me. Okay. Okay, so the scaling group is deleting. Let me delete this one too. And let me delete this one too. This may not be able to delete it, but let me try. Okay, it's been deleted. All of that. All right. Now let me take a look at the instance now. Probably take a look at the instance to see if it deletes the instances. This is the one that is running. So we have to create one on my own, right? So anything, just launch it. I don't care what it is. It's simple, no key. And then I just launch it. So I'm gonna grab this ID and I'm gonna put it in the Lambda function. So I'm gonna put it here. And that's it, simple, okay? So this, I'm gonna test it, right? I'm gonna test it. Let me wait for that instance to run. Oh, it's running already. Good, right? Let me check. It's running already. Where's my instance? This is the one, right? 96C. That's the one. Okay, perfect. All right. I'm gonna make sure that it's running. So now I'm going to stop it. Let me just come here and test that guy. Where it says it's test here, I just click on test. Let me just call it not anything I want. Doesn't matter. This is just an event. I'm gonna create that event. I'm gonna say test. I'm gonna test that. The execution succeeded. Then I have here hello from Lambda. Why am I getting hello from Lambda? Okay. Okay, let me see. Still running. What happened here? One moment. Just give me 1 second. Status code 100. Okay. 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 So now, start request, test, parameter validation, value type parameters, value type class str. Okay, list tuple. Okay, one moment. One line is that value parameters, value Okay, instance IDs. Okay. Instances. Okay. Instances. 2, 3. Okay. Guys, you have no idea how many times I've done this. Another nose. It's so EC2 bottle 3 client EC2 region name and then region, right? Did I create this instance in Northern Virginia? Okay, that's fine. Northern Virginia, okay. And then Lambda handler. So 2 instances, so 2 IDs equals str here, print, stop your instances. Value type parameter for instance ID value. Okay, let me see something here. Let's try that now. Parameter validation error, parameter validation fail. Invalid type for parameter instance IDs.
Do you have that instance?
I do. It's right here. It's right here. And I copy this guy here and I put it here. Okay. So instances is this region. Let me see if this is region and Lambda handler stop instances. Guys, if this doesn't work, I'm not gonna spend time on this. I will figure it out later. But believe me, I've done this so many times. So many times. I don't know what's going on now. I always save my notes in, and I don't know what's going on here. Probably AWS changed the way it is done or something. I didn't have this plan. It's just decided to do it using my notes, but seems that I don't know. A moment. Okay. Just give me 1 second. 1 second here. So give me 1 second. So here. Okay. By the way, guys, how many of you are doing the exams that have been posted every day? Are you guys taking the exams?
Yeah.
Yeah.
Okay. 1 second. I'm trying to find that. I will have to do that later. I'll wait to find it. Yep. Well, it's telling me that the parameter validation failed. Invalid type for parameter instance. Okay, you're telling me that it is a parameter that is run. Then I'm gonna give you this. This is and if I just save it, before they had a save button here. They removed that button. Okay. So still I'm having an issue here. Right. Now it's telling me that the same error. All right. Let me do something. If you give me the error, let me just comment this guy.
I was about to say they removed the print.
Yeah, let me comment that guy. And see what happens. All right. Now it gives me another error. Value type. Why do you give me the same error? Am I just commenting this guy? It's commented. Comment it out. Okay, let me deploy this. Okay. Let me try that now. Okay, now it works. Okay. So now let me check something here. Let me check my instance and see what's going on. Oh, it's stopping. You see? It's working now. Stopping. So if you're giving me issues with this STR, okay, I just commented out and that's it. Done. Forgotten. Okay. So what I can do now, real quick, guys, real quick. What I can do now is just restart that guy. Restart it, right? And I will restart this guy. Right? And then I can do something here. Okay. Okay. I can do something here. I can say the Lambda function is EC2 instance, right? I can come to CloudWatch. CloudWatch here, CloudWatch. And just put CloudWatch. This is the beauty of this, okay? CloudWatch. And then in CloudWatch, I'm gonna come here and create a rule. See rule here? And I'm gonna create a rule. I have these rules already here, okay? But I'm going to delete them, okay? Or maybe create another rule, okay? So this is gonna be a schedule and it's gonna be a cron job, okay? A cron job. So what I'm going to do, what time is it? And this is UDT time. This is not Eastern Standard Time. This is different. Okay. So I'm gonna put this here, and I'm gonna say, what time is it? It's 6:11. At 6:30, that's gonna be the first value is the minute. So it's gonna be 6:30, right? And then 6 from 0 to 23, right? And that's gonna be 6 is 18, right? But we have to change this because it works in UDT time, not Eastern Standard Time. So I'm gonna do this at 6:30, right? And the day of the month is today is 30, right? And it's gonna be the month is gonna be 9. The day of the week is gonna be maybe Wednesday, and the year is gonna be 2020, right? So that's gonna target a Lambda function. So I'm gonna say here, stop my EC2 instance. That's gonna target that, okay? So I have a problem here. It's not giving me the time here. Okay, so I can use,
That doesn't look like a cron expression.
yes, for AWS it is.
Oh, where did you get the translation to this?
The translation is an AWS website.
Oh, okay. Did you just look for AWS cron translation?
Yeah, it's on the AWS documentation.
Got it. Thank you.
So I can say, for example, run, let's say it will run at 8 a.m., right? And it's UTC, right? What time is UTC now? UTC now. It's 10:13. So it's 4 hours from now. So it means that 6:30 is gonna be 10:30, right? So let's say it's gonna be 30 and it's gonna be 20, right? 20:30, it's gonna be 6:30. And then it's gonna be, let's say that we want it to be every day, every year, right? Every day of the week and every this, right? So that's gonna happen on Thursday 1st at 10:30 GMT. Okay. Why is not 10:30? It's 4 hours ahead of us, right? So that's going to happen tomorrow. It's GMT, not UDT. It's GMT. Okay, that's a different time. GMT right now is 10:14, September 30. So right now, if I say 18, that's going to be October 1st, 18. Okay, and then I want to put here the day of the week is just question mark, right? Hours, day of the month, every day of the month, every month, every day of the week, and every year. That's what I'm saying. Okay. So it's gonna be a 6:30 every day, GMT, right? Now that's gonna be for tomorrow, and not for today. Okay, because right now it's 6:30. That's gonna be for tomorrow. So 20, maybe 22. Okay, that's gonna be today at that time, but you know, we don't want that, right? That's gonna be 10, right? 10:30. That's our time, 6:30. Okay, what time is it? It's 6:16. So let's test this. Let's wait until 6:30. It's going to stop the instance. Right now, my instance is running, is in a running state right now. Is right here. So this CloudWatch is going to run at 10:30 GMT, which is 6:30 our time. Okay, so now I'm gonna configure the details. I'm gonna call it new EC2 stop rule, right? So this will stop my instance every day at 6:30 Eastern Standard Time, right? 6:30 p.m. Right? So I create the rule, and it's right here. We just have to wait, you know, until it happens. So that's a cron job. Okay. That EC2 instance is going to be stopped every day. Of course, this will work only today because I don't have another Lambda function that starts that instance. So I can say that my instance will start tomorrow at 9 a.m. Okay, so I can go back to my Lambda function and copy that code, right? When I have this guy here, this one starts the instance. No, that's for Slack. Okay, so I have this guy here, stop my EC2 instance. I can copy that guy, right? I can copy that guy. I can create another function, and then I can say create a function, and then I can say start my EC2 instance, and then I can use Python. I can look for a role that I already have, and I can use exactly the same that I used before. I can use this one, start EC2 instance function. Okay, that's okay. And then I can create this function, right? Now, I can just delete this, and instead of stopping, I'm gonna say start. Okay, as simple as that. Now let me stop the instance so we can test that. I'm gonna stop the instance. I'm gonna stop it, and then we can test that to see how it works. Okay, so I'm gonna stop this instance, right? Right now it's stopping. Okay, good. Let me try that guy. Let me test it and create the event here. My event start. Okay. And then let's see if it's stopping here. Stopped. Let me test that. Let me save it. Right, it's saved. Let me test it. And it worked. Hello for Lambda. I don't know why it's printing that. So if I just refresh this, my instance is not, okay, I know what I have to do. I have to deploy it, and then I can test it. And it worked. So now, if I just refresh that, my instance is pending. It's going back to that. So now that I have my Lambda function, right? I can come, what time is it? Because I scheduled the one for 6:30. So I can come back to this guy, right? And now I can stop it again. I can stop it again. So I come here and stop the instance, right? Stop the instance, and now it's stopping here, right? And then I can come back to CloudWatch and create another rule, okay? So this time I'm going to start my instance tomorrow at 7 a.m., I'm sorry. So I create a rule here. So the one that I have in new EC2 instance stop, The other one is going to be called new EC2 instance start rule. Schedule, cron job. So it's going to be at tomorrow, the 4 hours is the difference, right? So it's going to be at 7, that's going to be 11, right? 11. And it's going to be this, then this, and then this. So that's going to be, and it's only 2 here, right? So that's going to be every day at 11 GMT, which is 7 p.m. our time, right? And I'm going to target the function that I just created, start my EC2 instance, right? Now, when I click on that, I just want to call it the same name, but instead of start. Okay, so this function of this event will trigger a Lambda function that will stop my EC2 instances every day at 7 a.m. Eastern Standard Time. Okay. And then I just create the rule, and that's it. I don't have to worry about this anymore. So every single day, this will start the instances at 7 a.m. and stop the instances at 7:30 p.m. every day, every year, every month. Okay. So this is very important when you have spot instances, right? Spot instances that they have start and end times that are flexible. So you can use cron jobs to do that. Okay. So now I'm going to wait until I have on the time comes 6:30. It's 6:23, right? And I will start this guy just to have it ready for that event, right? So I just spend it now, and let's continue the class. And we see that later, that after 6:30 it's going to be stopped, and then I can wait until tomorrow. You're not going to be able to see it, but if you watch the video, you can do the same and test it in your computers, in your AWS console, and you see that it works. Okay, that's called automation, right? Now, Lambda event sources. Amazon S3 has a section for Lambda. So if you come to EC2, S3 bucket, and then you come here and you see a bucket, any bucket you want here. Let me see this bucket. And then I come here to properties. I have a section that says events. So I click here on events, and no, that's not what I want. I have to come here to event, add a notification, right? I'm gonna pull a name, just whatever I need, whatever I want, just event, just a name. So if someone just put, which is upload an object, then I'm going to send that to a function, and then the function is going to probably whatever. In this case, I don't have a function to do anything regarding S3, but I can have a function here and then say my function .escape, save it. And then whenever someone uploads an object to an S3 bucket, I'm going to get a notification. The Lambda function is going to be triggered, and then whatever action you're doing with the Lambda function is going to perform it. Okay, that's another way you can do that. Let me remove this guy. I don't need this guy. I can select this and delete, and that's it, done. Okay, I don't have an event. Okay, so that's the way you can have Amazon DynamoDB when someone fetches the information from the database or upload something or add something to the database. You can trigger a function that tells someone has added information to the table. You can have SNS, right, which is a simple Amazon Simple Notification Service. You can have a queue, Amazon Simple Queue Service, SQS. You can have an API gateway. You can have an application load balancer, many more. Those are event sources, right, that can trigger a Lambda function. And of course, this guy that we just worked with is the Amazon CloudWatch, which is key for automation in AWS. Okay. So we continue, and now we have this Lambda configuration. Guys, you already saw it with me. You have the function code. You have the dependency code libraries. Remember that I imported Boto 3, right? You can import JSON too. You can import the other libraries that you can import depending on the language that you're using. Remember, you can use several languages like Java. You can use Node.js. You can use Python. You can use Go, Ruby, different languages, right? And then you will have a role. You will need a role to work with Lambda. Lambda without a role, we're not able to do anything because remember, Lambda that's interacting with other services, right? You have a Lambda function. You have here the execution of the code only when it's triggered. If you don't trigger the Lambda function, it will never do anything. Okay, it's like if you guys know programming, you know that a function will not do anything unless it is called. Okay, you have a function or a method in Java or JavaScript or C# or any Python. If you don't call that method or function, it will not do anything. The same here. If you don't trigger a Lambda function, it would not work. But Lambda accomplishes the same thing as EC2 instances, and it is even more effective because it is serverless. The only problem that Lambda has is that it has a limitation. The application can only run for 15 minutes. If your application is to run, it needs more than 15 minutes, then you cannot use Lambda. Lambda is not the service for that. You will have to use something else called step functions, when you can have several functions in the same orchestration. But one Lambda function will not be enough. Okay, it's 6:28. We're just about there just to test the CloudWatch cron job. So schedule-based event based Lambda function example, start and stop Lambda function. That's what I did, guys. That's exactly what I did. I just created a CloudWatch event, a rule, I'm sorry, and then you have the Lambda function trigger, and then the EC2 instance stop. You can do the same. You can just the inverse process. Instead of stopping, you start the instance. Okay, nothing new for you guys. You already saw it. Event-based Lambda function example, create a thumbnail images. With the Lambda function, you can create a thumbnail. Okay, so the user, right? Sorry, oh my God. So the user posts, an image or puts an image in an S3 bucket, right? Then that will trigger Lambda function. The Lambda function has a role that accesses the EC2, the S3 bucket, right? And then it will create a thumbnail and put it in another bucket. So this is the source bucket, right? That's the source bucket where the first image, the original image is, right? The Lambda function will be triggered when you put, remember that I just demonstrated that there's a section for events that you put, and then it triggers a Lambda function, the same thing here. Then Lambda needs a role to work with S3 bucket, for the S3 bucket. Otherwise, no way, Jose. There's no way. Now, based on that access policy that role has, then the function will do their job, right? And create the thumbnails, and then we'll post in another bucket. There's a target bucket. So you have to have two buckets, one for the regional pictures, the images, and one for the thumbnails, okay? Now, it has limits, right? It has limits. So it's not the best service when your application is big, right? It has soft limits per region. A soft limit indicates that you guys can modify that by requesting it to AWS. You request a change from AWS, they can increase your limits, and that's possible. Hard limits, there's nothing you can do, okay? Concurrent execution, so executions that can happen at the same time, 1,000, no more than that. That's the limit. You can increase that, requesting it, but by default is 1,000. Function and layer storage, 75 gigabytes. You can create layers in a Lambda function. If you come here to Lambda, you have something called layers that you can create on top of the function, right here, layers, right? You can add a trigger, you can add a destination. There's so many things that you can do with Lambda functions. Now, hard limits for individual functions. The maximum function memory allocation is 3 gigabytes. So if you come here at the end of the function, where is this? Okay, permissions, monitoring, configuration. Okay, what happened here? Okay, let me come to another function here. Maybe this one. Yes, wow. Didn't see the other ones go. Good, so we have this is the reserved concurrencies, 1,000. And the memory, right, one moment. Memory, I can edit this. And then the memory that you can have is 3,008 megabytes, almost 3 gigabytes. All right, so that's what you have. And then the maximum minutes is 15, no more than that, okay? So this is the maximum. If you go over 60, it's gonna give you an error. If you run an application or a small program and it takes 6 seconds and you have 3 seconds by default, then you can come to the function and increment that to 6. And then the function will have time to process the application, okay, to work with the application. But if it is more than 15 minutes, guys, you cannot work with it, okay? You cannot work with it. 15 minutes is the limit that a Lambda function has, right? And the deployment package size is 250 megabytes unzipped, including layers. So there's a section here where you can unzip the files, okay? Unzip a file. You can have your Lambda function or your code in a file, or you can have it in an S3 bucket and just bring it from there, okay? And put the code here, okay? And of course, you're gonna have all the, the file system here, all the directories and files. This is the one that I have right now, right? Okay. So additional limits also exist. Details are in this. You can search this Lambda function limits. Okay. Now the takeaways. What time is it? I think it's 34. I think that EC2 instance should be stopped. Let me take a look. There you go. Stopped. Okay. So the cron job worked. Okay. Now tomorrow, I'm not going to be able to show it to you guys because tomorrow we don't have classes. We have classes on Friday. Tomorrow at 7 a.m., this EC2 instance will be up and running again. Okay, that's the way it is. That's the way you automate that. Okay, you can do tons of things with Lambda. This is one of them. Okay, super cool. All right, takeaways: serverless computing. That's Lambda. Enables you to run and build applications and services without provisioning or managing services. That's the important thing about Lambda. That's the huge difference that puts Lambda in the map compared to EC2. It's serverless. That's a lot of overhead that you don't have to worry about, a lot of work that you don't have to do with this. It's a service compute service that provides built-in fault tolerance and automatic scaling. It's fault tolerant by default. It is highly available by default. It is scalable by default. None of that happens with EC2 by default. With EC2, you have to create backups, recovery, disaster recovery plans, You have to have auto scaling to be able to scale in or scale out, not with Lambda. That's why Lambda surpasses and is more excellent than EC2 instance. The only difference, and I think is a remarkable difference, is the limits that it has. So an event source is an AWS service or developer created application that triggers a Lambda function to run. I know companies, and I've worked for one, that they're using Lambda only. They're not using any EC2 instances. All the developers, they're trained to use Lambda. And if you know a language, that's all you need. What you need to know is how to use Lambda. That's it. So the maximum memory allocation for a single Lambda function is 3008 megabytes. Don't forget that. Those limitations are important. The maximum execution time for Lambda function to run is 15 minutes. That's the maximum, 15 minutes. They can trick you in the exam and tell you 25, or maybe 5, or maybe 20, or maybe 10. It's 15 minutes. And the most memory that you can have for a Lambda function is 3008 megabytes. Okay? And for unzip packages, it's 250 gigabytes. Don't forget that. Right? Megabytes, I'm sorry, not gigabytes, megabytes. So we don't have that. Well, we have the lab. We're gonna do the lab later. So Elastic Beanstalk, you know, this guy, we talked about this guy so many times, right? So many times. Guys, we're gonna have the break at 6:45, okay? So this guy is a web application guy, okay? This guy has the power to build. It has the power to scale. It has the power to deploy. And it has the power to create so many services for you. Good. It's a managed service that automatically, you know, this word is super important, automatically handles everything for you. Everything. This is virtually everything. Infrastructure provisioning and configuration, deployment, load balancing, automatic scaling, health monitoring, analysis and debugging, logging. Guys, my question is, what else do you need? That's the whole package. This is the whole package design. The only thing that you need to do, you have to develop your application. You have to code your application. Okay, that's, you know, if you're a developer, you have to do something, right? You have to develop something. You're a developer, right? So Elastic Beanstalk is not a developer, right? It's a web application service that will deploy and provision everything that your application needs. That's what's going to happen. Like I said before, and like it says here, there's no charge for Elastic Beanstalk. Elastic Beanstalk is free. You only pay for the resources that Elastic Beanstalk will create for you. Okay. Now it supports a lot of platforms like Java, .NET, right? PHP, Node.js, Python, Ruby, Go, and Docker. So it also has, you can have multi-containers. So if we come to Elastic Beanstalk, right? As you see here, Elastic Beanstalk, right here, and you create an environment, right? Let me see here, create an environment. So a web server, and I have here, and I can choose the platform, right? I have here a platform. Okay, what happened here? They changed this. It had Docker and multi-containers. Okay, it seems that they changed that. Okay, well, it's the way it is. That's it. It is what it is. Okay, so okay, Elastic Beanstalk, multi-container Docker environments, Elastic Beanstalk. You can create Docker environments that support multiple containers per Amazon EC2 instance with multi-container Docker platform for Elastic Beanstalk, and that's taken for the AWS documentation. So Docker, and then we can have here Docker, So it seems that they changed that because there's nothing here about multi-container, and it was there before. Okay. It says Elastic Beanstalk uses Amazon Elastic Container Service, Amazon ECS, to coordinate container deployments to multi-container Docker environments. Amazon ECS provides tools to manage a cluster of instances running Docker containers. Elastic Beanstalk takes care of Amazon ECS tasks, including cluster creation, task definition, and execution. So this is the multi-container thing. Okay, this is the multi-container thing, right? So it's not something that I'm making up. Is this something that you can do with, Elastic Beanstalk? So before it was there, I don't see it anymore. It's multi-containers, right? It seems that they changed that. Okay. I don't see it anywhere. It used to show here. Oh, right here. Why did I see that before? Okay, multi-container right here. Sorry about that. I didn't see it. Okay, so multi-container is right here. You can have multi-container Docker running on 64-bit Amazon Linux. Okay, so you upload your code, right? This is what you manage. The code. That's it. You don't manage anything else. AWS manages the HTTP server, right? The web browser, right? The application server, the language interpreter, the operating system, and the host is doing everything because it's a managed service. And remember, don't forget this, platform as a service. You only develop your code and upload it to Elastic Beanstalk. Okay, so you upload your code. Elastic Beanstalk automatically handles the deployment, deploys on services such as Apache if it is a web server, Next if it is a web server, and Passenger, Puma, and Microsoft Internet Information Services, IIS, and all these kind of servers. Okay, that's what we do for you, depending on your application. Okay, so benefits of Elastic Beanstalk. It's fast and simple to start using. Guys, you saw how fast that is and how easy it is to use Elastic Beanstalk. It's so easy. You just select the platform. You're doing it in Python, and you can use Python any type of supported version here, right? These are the ones that are deprecated. Okay, I will choose the latest one, and then the Plumbo version, that's the one that is recommended. I can use a sample application. I can load the code here, whatever code I have. I can have it in a local file. I can choose the file from my computer, or I can bring it from an S3 bucket. I can put the URL here. Okay, and I can use tagging. But in this case, I'm going to use a sample application in Python. And you see how easy it is. I just created the environment. What happened? I forgot to put the name. Okay, let me say my Python Elastic Beanstalk environment. Sample. Okay. Okay, what else do we need? Yes, it takes the same name. Domain, I don't have a domain. This is just in case I have a domain, right? That I can use, but by default, it's gonna be this one. If I say, maybe, no, it's gonna be that one. If I have a domain, and then it's gonna be added to this, but then you can buy a custom domain and then change the domain. Okay, now it's creating the application for me, the environment, and then let's wait and we'll see later. So it improves the developer productivity because, as you don't have to do anything but uploading the code, then you can, spend your time on doing something else, and your productivity is going to be improved because you can accomplish more. You don't have to worry about any of these layers here. Okay, that's why you can employ your time doing something else. It's difficult to outgrow because it's unlimited. It can scale unlimitedly. There's no limit for Elastic Beanstalk. So can you outgrow that? That's pretty difficult. Okay, and complete resource control, because you have a section that says configuration, and then you can see what's going on there and just have that. So it's created this out of these guys for me. right? And I will see that later, right? Now, takeaways of this guy: Elastic Beanstalk enhances developer productivity, right? It simplifies the process of developing your application. It reduces management complexity. It supports Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker. There's no charge for Elastic Beanstalk. You only pay for whatever you produce with that. Okay, guys, let's wrap up and then finish here, and then we come back after the break. Okay. So summary: what did we learn today? We had an overview of differences between AWS compute services in the cloud, right? Different, like Elastic Beanstalk, container services, Kubernetes, Lambda, all those guys, EC2 instance, Fargate. We demonstrated why to use Elastic Compute Cloud, Amazon EC2. That was on Monday, but still is part of this lesson. Identify the functionality in the Amazon EC2 console. Perform basic functions in Amazon EC2 to build a virtual computer environment. Identify Amazon EC2 cost optimization elements. Demonstrate when to use AWS Elastic Beanstalk. Demonstrate when to use AWS Lambda, and identify how to run containerized applications in a cluster of managed services. Now, after class, before we do this check, after class, after the break, we're going to first, we're going to take the knowledge test, the knowledge check test, which should take about 10 minutes, no more than that. After that, we're gonna do a lab, which should take about probably 30 minutes or 40 minutes. And then after that, we're gonna come back and we're gonna create some resources from the CLI, okay? And you're gonna follow me and we're gonna do it together, okay? That's what we're gonna do. That's the plan for after the break. Now, sample question: which AWS service helps developers quickly deploy, resources which can make use of different programming languages, such as .NET and Java? Come on, guys, you can answer that.
C.
C is the answer, okay? This is a little, moved a little bit more, but the answer is 3. It's C. Okay, so that's it. Now, guys, again, every day you are receiving exams to do, right? You're receiving exams, my exams, okay? Don't forget to take them, because on Friday, we're going to schedule the exam, right? And the exam is gonna be on next week or early the next week, depending on the availability. You guys need to study. Don't leave everything for the last minute. We have to study. You have an exam that has 65 questions every day and is free for you. You have a cloud guru as well that you can use for that exam. If you pay attention in class, if you take the exams, if you do your own exams or you do your own knowledge check tests, if you do that, there's no doubt in this world that you will pass that exam. I can guarantee it, that you will pass that exam. But you have to put in the effort, you have to put in the time, okay? I'll see you in 10 minutes at 6:59. At 7, let's make it 7, okay? I'll see you in 10 minutes. Okay, guys, let's work on the knowledge check. Okay, so it should be here in Canvas on the module 6. So if you come down here, you can find this module 6 knowledge check. Okay, and then after that, you're gonna come here. It says Lab Introduction to Amazon EC2. Okay, I explained what the lab is gonna be about on Wednesday. On Monday, I'm sorry. So here, when I take a look at here, I see that a lot of people have been taking the exams, but still there are people that haven't taken anything. Okay, so guys, that's very important. Florentina, very important that you take this knowledge check. Okay, Aussie, very important that you take this.
No, I took it. It's repeated. I have to. I have to remove one, I guess.
Sorry.
You good?
Okay, Tanner. I don't know if Tanner's here. Maria Roscoe, Charles Pertwee, Mohan. Very important that you take that. Okay, that's very important, guys. This is this is serious. This is about your exam, your future. So don't forget that. Let's work on the knowledge check number 6, right? And then after that, let's work on the lab that is already open for you guys. Do you have any questions before you proceed to do this? Any questions? No questions? No questions whatsoever? Okay. Questions? Okay, guys. Don't forget that we're almost around the corner. I mean, around the corner is the end of the course. We only have basically 3 more classes, and that's it. Okay. So good. Work on that, and then we're gonna meet back here at about 45 minutes when you finish both activities. Okay. Thank you. I'm gonna put you in a team so you can work in teams. Okay. Davin, Dania, Dieva, Haro, Anusha, Demetrius, Lauren, Aussie, Ruben, please accept the invitation to join. Fernando, Maria Orozco, Admaro. Fernando, Maria, Demetrius. And then we created users here in the dashboard. Remember that you configure the CLI. Do you remember that?
Yeah.
Okay, let's open the CLI now. And let's create an EC2 instance from the CLI. Okay. So let me know when you're there. If you do this and you get an error, it means that the CLI is installed. If you don't get anything, it says command not found, it means that you haven't installed the CLI.
Solid.
Remember to configure the CLI for your account, you have to put AWS configure. Don't forget that. Okay? That's very important. Okay? So let me know when you have done that, guys.
Working good this side.
So the first thing that we have to do is don't close your AWS account, okay? That's very important. The first element of this command line command is AWS. That's the first element. The second one will be EC2, right? And then the other one is the operation that we want to create. That EC2 run instances is the way you create an EC2 instance in the CLI. So let's just create that. Just put in the type, the instance type, right? And when we have this thing here, remember the first word, all the options, they have 2 dashes, the first word, and then 1 dash and the second word, right? If it is only 1 word, we don't need to put any dash in between. If it's 2, you have to put that. So we're gonna choose the micro, T2 micro, which is the instance type that is free in the free tier. That's the eligible for free tier. Okay. Now the image ID is the other one, right? The image ID. Then that one we can get it from here. So we come here and we say EC2 instance, right? In the console. And by the way, let me show you the environment in Elastic Beanstalk. Remember we created a Python environment. If I click here in the URL that I'm provided from AWS, by AWS, I see here that I have a web application written in Python. Okay, so this is a sample that AWS has here in Elastic Beanstalk. So I'm gonna delete this guy, and everything that it was created with it will be terminated. Okay. Now it's being terminated. Okay. So now try to come here and just click on launch instance, right? Launch instance. That's an EC2 console. And let's grab the AMI from here. You see the AMI here? This is the AMI ID, the image ID. Okay. Again, we find it when we click on launch instance, and then we launch the instance here. The first step is to choose the AMI. You can grab the AMI ID from here. Okay, so now you can come here and paste it. Okay, that's the AMI. The AMI is important for creating an instance. If you don't have that, you will not be able to create it. Okay, now we're gonna do a count. We're gonna create 20 EC2 instances. Let me see how many I have now, because I have a limit of 20.
If we are not administrator or we don't have access to the console and somebody provide us the client and I want to create that, I have a place where I can see every type of MI. Like, okay, I want to create this one because I know if I go to the console, I can see it, but if I don't have access,
you can use the ADKs for that.
Using the SDK, okay.
Yeah, you can bring that from a pool of images, but then you have to use a CloudFormation and things like that. Use mapping and things like that to be able to bring that those images. The company should have images too. All right.
Okay.
I'm taking this from AWS is just an example, but the company should have their own images and things like that, because remember, sometimes computers and virtual machines are customized. So you have your own image that has the software that you want to install, the operating system that you want, and things that are customized.
Right.
This is just an example. It's just a standard image that AWS provides. So I get it from here. So right now I don't have any instances, right? So I can create 20 instances. That's my limit. Okay. So now the next thing is the region, right? The region, and the region is going to be US is one. Okay, I'm not using a security group because by default is gonna use the default VPC and the default security group by default. Okay, I don't have to worry about that for now. This is just an example to show you guys how to create an EC2 instance. As remember that when we configure the CLI, we chose JSON as the format, as the output. So now when I create the instance, it's going to show me in a JSON format what was created. Okay, so you see here the image ID is the one that I selected. The instance type is HTTP2 micro. The monitoring is disabled. I'm talking about the enhanced monitoring. Availability zone is US is 1. That's the one that it was chosen by default. The tenancy is default. The DNS, the private one is like this. We still don't have a public DNS because it's in the pending status, right? But if I have here state transition, VPC is going to be the default one. What else? The security group is going to be the default one. The IPv6, there's nothing. MAC address of this virtual machine is this one. Owner ID, that's my account number, right? Private DNS, private IP address, right? And things like that. And all the information about that particular EC2 instance, as you can see, is a lot of things. Okay. Now, I can, of course, this includes also it just prints the one that are terminated and things like that. So now, if I just say AWS EC2, and I say describe instances, right? And then I say instance ID, and let me see. Describe instances, and then it will give me a description of all the instances, right? Right now, the one that I just launched is stopped. Well, actually, this is not the one that I launched. This is the one that I stopped, okay? So what I can do is just come here and, oh, it's great. 20, you said 20?
Yes, you put 20, I had 20.
20 instances. So if I come here to the dashboard, I see that I have 20 instances running. Crazy, huh? So I can just come here and say, accept these two, delete the other ones. Okay. Terminate the other ones, and they will be terminated for me. All right. So shutting down all of them. So we created an instance from the CLI, right? So this is one way. So maybe I want to create a user. How about that? I can create a user from the CLI. right? And I can say AWS, right? I am, because the user is I am. Remember, the first word is AWS, and the second word is the service, okay? So now I can say create user, as simple as that, right? And then username. And then I can say Bob, for example. Okay. So I can do that. And then if I just hit enter, it says Bob, user ID this, and the created date is, tomorrow, because this time is different time from ours. It says here 12:50. Okay. What time is it? Yeah, it's 8. Remember that AWS is the 4 hours is GMT time, and is 4 hours ahead. So right now is 12. Right. Now, if I can go to the CLI, to the console, and check in IAM that I have a user and the name is Bob. Okay. So how's it going, guys? Could you do it? So how about adding a user to a group? How about that? So we can say AWS, right? So we're adding a user to a group. And of course, it's IAM, right? Because IAM is the service where we create users, roles, groups, and that. So we can say add user to group, right? And then we say the username, let's say is Bob, right? And let me see the groups that I have here. Let me put Bob in the administrators group. You see here? So I'm gonna say group name, and then I say administrators. Okay. Now, if I add that, what did I do wrong here? Oh, I know what I did wrong. Username is not one word, it's 2 words, so I have to put the dash in between. Okay. So now if I do that, then it should tell me, it doesn't give me anything, but if I refresh this, I see that there are 2 users in the administrator. It was 1 before, and now Bob is an administrator. Okay, so Bob can do anything he wants in AWS account, right? What else can we do? So how about let me see here. How about removing Bob? Okay, deleting Bob. Right, so we can come here and just say simple. This is nothing difficult. It's just, we say here, quit, and then we say AWS IAM delete user, and then we say username, and then we say Bob. That's it, simple. And of course, I'm missing 1 dash here. It's 2 dashes. And then I can just hit enter. And then an error occurred, the complete when calling the delete user, cannot delete entry, must remove users. Okay, okay. Okay, let me do that.
Remove from the group first
Yeah,
before
yeah,
delete, right?
It has a dependency.
Right.
Yeah. So we can do this. We can do this. AWS IAM, right? Remove user firm group, right? Username, Bob, and then group name, administrators, right? Now, if we go there and refresh this, we see that Bob is not there anymore. So now I can come here and just apply what I did before. And then now Bob can be deleted easily. So if I take a look at this and I see users, I see that Bob is not there anymore. Okay. What else can we do? Okay, maybe create a group. Okay. So we can do create a group, right? So we can say another group here. We can say clear, and then say AWS IAM, create group. And then we say group name. Let's call this group educators, right? Hit enter, and the group was created. Right. Now, if I come here and check the groups, we see the educator is there. Okay. So you can do all this in a different in CloudFormation and things like that. Okay, it's not only in the CLI only. The CLI is just one way to use it, to just add users to groups, create users, things like that. Okay. So that is one way. What else can we do? Okay. There's a lot of things that we can do. Let's do something, let's say here. Let's try to add a function, a Lambda function from the CLI. It's a little more complicated. than it is. Okay, let me see here if this, it's efficient here. So I'm going to create a script, right? Okay. I'm going to create a script, and then I'm going to say nano lambda function. And then sh. I'm going to say this bin dash. And then I'm going to say this AWS Lambda create function. And then I'm going to say this. I'm going to say function name. I'm going to say my CLI. I'm going to say, what this does is that it lets me do separate lines. Okay, I can do the options in the separate line. I can do the same in the CLI. Okay, so the runtime is going to be node JS10 .x. And then the handler is going to be my function. Handler. Right? And now I'm going to choose a role. So say role. And the role, I'm going to come here and choose a role for this particular Lambda function. And then we look for a role here, and we look for, let's say, EC2 as an example. EC2 to Lambda. Okay, I just grab this number, the ARN, which is the Amazon resource name, and I paste it here. Okay, so we still should have, I mean, we may have a problem because we don't have the code. Okay. If we can have a zip file that contains that, okay, let me see if I can grab this information from the Lambda function, right? The Lambda function here, let me just grab this information from here. And then I'm going to grab this code, right? I'm gonna put it in a file. So I'm gonna open VS Code and a new file. New file, right? I'm gonna use Python. And then, don't worry, I'm not concerned about that. I'm not concerned about that. So I'm gonna put this code here. I'm gonna save it as my code, .py, and I'm gonna put it in the desktop. All right. Now we change that, and the environment should not be node.js. It should be Python, the runtime. Okay. Just one moment. Okay. So I'm gonna use in the CLI, I'm gonna use runtime Python because my code is in Python. So I'm gonna say Python, and here I used what runtime? I use Python here, Python 3.8. So I use Python 3.8. And then the code is gonna be, I'm gonna zip that file, right? I'm gonna zip that file. Let me see. I'm calling my code. Okay. Guys, you still there?
Yes.
Okay, I'm gonna just compress that code. Okay. So I'm gonna say zip file. Zip file. And then I'm gonna say file B. Say file B. Okay. And the name of the function is, the name of the code is my code that py. That's it. Okay. Not 100% sure about this, guys. Okay. So now I just give permissions to the file. Okay. Lambda function. Okay, that I create that in the okay. So what if I do this now? Fingers crossed. I knew that something was wrong. No slash file directory, my zip code. Okay. So maybe if I do this, probably okay, no, this is okay. Oh, this isn't my computer. My computer is a mess with paths and all that. Oh. So everything else is fine. The only problem that I see is the file. If I do this in a Linux machine, it's easy to find that file. Okay. Pass the C file of the code you are uploading specifies C file code, but not both. Example 5b. Yeah, but okay. Okay. Guys, I will have to get back to you with this because the path is complicated with Mac. And it's it's the AWS CLI, and to get together working with the CLI with the file system in my computer, my computer. Okay. 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 Let me put that in an S3 bucket. Let's see what happens. Put that code in an S3 bucket. Say bucket Lambda. Okay. Okay. So the Lambda function, we have to have a role for S3. Okay. So now I'm going to say Lambda, and I'm going to load that file. Okay, here. This is my code, my code, my code, my code, my code. And then I upload that guy, right? So now I have to find a role that allows Lambda to communicate with its S3. So I have to come here and say Lambda. And then see Lambda, S3 Lambda. So this one we have Amazon S3 complete this. So I'm gonna come here, and instead of having this guy here, I'm gonna delete this guy. And just write this guy here. Okay, that makes more sense now. Okay, now, I don't know know if this is gonna work. So I'll run it again. And now I get a different arrow. That's a different arrow. It's not the same. Did I change something here? Oh, okay. And what happened? Oh, I forgot to put this here. Okay, so roll now. Oh my God, same thing. Okay, guys. So the way you do it is this way, you know, for example, if you want to put more things, just a timeout, right? Timeout, there's 5 minutes, 5 seconds, and then probably memory size, right? Memory size 250, right? And then the handler is gonna be my function handler. All right. So this is the way that you created Lambda function. Guys, I promise you that I will get back to you with this, because I was doing the other operations and then I decided to go with this one just to see, you know, experiment, and it's not working now. So I'm gonna get back to this and find out what's going on here, right? So I'm gonna show it to you on Friday, okay?
Okay.
Could you guys do the other ones in your CLIs?
Yes, I
Yes. Do you guys know how to use Nano, this text editor, to create this?
Oh,
Nano is a text editor for Linux, but you know, in your case, if you have a Windows machine, you're not gonna be able to use Nano because Windows does not recognize Nano. Mac does. Okay, what you can do is create the file in
Notepad++.
I'm sorry.
Normally I use Notepad++.
Okay, good. So what you can do, guys, is copy this and paste it in your CLI. Okay. So you can come here, clear, and then do this and run it. You're still getting the same error, right? So command not found, rolled. You see? Oh, because oh, of course, man. Of course. So if when I do this, when I copy this, what happened? So let me go back to Nano. I forgot to put this guy's, you know, to put this guy here, the backslash here, and the backslash here. Okay. Now if I do this, I get a different error. I get the zip file. This is the only error that I have. It cannot find the file. Okay. Don't worry about this. I'll get back to you guys with this on Friday, and then I can show you how to do it. Okay. So don't forget to continue studying, right? The exams are coming every day. Tomorrow you're gonna have another exam at 8 a.m. Please do them. Just take advantage of time. We're gonna be scheduling the exam on Friday, so we need to be ready for that exam. Okay. So have a great night, and I'll see you again on Friday.
Okay, Professor, have a good night.
Professor, thank you.
You too.
Thank you.
Good
Night.
night.
Thank you.